So Jiva, we've sort of looked at OOP, object-oriented theory, and did an overview, but I guess we now need to sort of, how do we build to construct this stuff? What does it look like in Objective-C?
Right. So when you're defining objects, when you're trying to model those relationships that we talked about just a moment ago, in Objective-C, Objective-C provides a bunch of language constructs for us to do exactly that. We can basically model those objects in the language. If we look at an example here, so essentially, first of all, just like when we were dealing with functions, there's a .m and a .h file associated with a class. So you can define a class and you can define it. You put the interface definition into the .h file, that's the interface, and then you can put the implementation of the class into the .m file, just like you did with functions. Now, you're not limited, you can't, that doesn't mean that you can only have one class per .h, .m combination. You can define multiple classes in any given .h or .m file. But typically, I would say that the standard, the consensus generally is to have one class per file is kind of the idea. You know?
Right, okay.
I think that's a good practice to have. So when you're actually defining a class in Objective-C is sort of a two-part affair, right? There's the interface and there's the implementation, just like those functions. The interface is put into the .h file, and it's actually started off with the @interface directive, okay? And what you do is you define this @interface, and then you say the name of the class that you're trying to define. So in this particular case, we're declaring that we're going to create a class called foo.
And just remind ourselves that our class is our template from which we will
Exactly.
create our instances later on.
Exactly.
Okay. Can I just say that this @interface, we've not seen anything with an @ before. Is this an Objective-C construct we need to get used to or something?
Yeah, Objective-C uses @such and such for a lot of its constructs. Like you'll find like @interface, @protocol, @class, and I'm not really sure the exact history of why that's the case. I think it has to do with having been a character that wasn't really being used in C, and so they used it to sort of for most of their extensions to C.
Okay.
So there's this @interface directive, and in this particular case, so we're saying @interface foo. That's going to be the class name. Like for example, if we were defining our dog class here, that would be dog. Then we have a colon, and then we have the class that this class inherits from. In this particular case, it's NSObject. Now, in Objective-C, Objective-C is a single inheritance language. So in other words, everything ultimately will inherit from one gigantic superclass, and that class is NSObject. That's the top-level class that all other classes in Objective-C inherit from. In this particular case, we're actually inheriting directly from NSObject.
I think it's worth pointing out that the NSObject is actually part of Foundation, isn't it?
It
that
is.
we were looking at.
Yes.
I think you can go back to just object if you really want to use very raw Objective-C, but no, you're never going to do that.
Right. I think actually...
But this is why we need to include Foundation, because we get this base NSObject.
Yeah, NSObject comes from Foundation. It's part of the Apple Objective-C implementation. I think that you would find that I don't think there's an object in Apple's Objective-C. I think there is, however, an object like if you went to, say, another runtime, for example, on Linux or something like that. I think some of them still use object. But generally speaking, you're never going to see it.
Confusing.
NSObject is where it's going to be.
I'll shut up now.
That's all good. So this construct here is saying, I'm going to create this class, and it's going to inherit from NSObject. Then we have these curly braces here, and these instance variable declarations, or these member variable declarations. That's what this particular block of code here is. And these are where you define all of the attributes of your class. So these are those things like, you know, the fur color and the eye color and the height and the weight and things like that. That's where you would define those particular variables. So that's each one of these here is going to be a member variable of this class. Now, interestingly, you know, when we learned about declaring variables before, we learned that variables are scoped by their curly braces. And in this particular case, it's true and it's not true, right? These particular variables, when you're defining member variables on a class, they are in scope for all of the methods that that class implements.
Right. Okay.
It's not just limited to these curly braces right here. These variables will be in scope on all of the methods of this class.
Okay. So because this is the class definition, they're in scope for the class. Anything code we write for the class.
Correct. Now, so after the member variables are declared, then you also have a section, typically, this is another one of those Objective-C 2.0 features, that define properties for accessing those member variables. Now, we'll get into properties specifically later, but I just wanted to point out that this is where those property definitions go.
Okay, so that's where they are. We'll worry about what it means later on.
Exactly. Then finally, you have the methods. These are those methods that are declared for this particular class, right? These are the declarations for those methods. So again, this is all interface. We don't have an implementation here. We just have the declaration for these methods. Now, you might look at this and you might say, well, that doesn't look like, these are similar to those functions that we declared before, but this is a totally different syntax. And again, this is part of the Objective-C part of Objective-C. This is that extension. When they created the object-oriented extensions to Objective-C, they wanted to also include the ability to have essentially named arguments, so that you could say that so that your methods could be self-documenting. So you might have such and such method with argument A and with argument B and stuff like that. And in fact, actually, that's what we see here on the second method, where we say this is defining a method. Again, going back to our function definitions, right? We had our return value. That's the first thing that we see right here in parentheses. The return value on method definitions is always given in parentheses, just like this. Then we have the actual method signature, which is all of this stuff here. Now, technically, the actual method signature winds up being this and this part right here. So in fact, it's more like some other method with arg and then and another arg. That's the actual method signature. This is actually the parameters for that method. So just like we had parameters that we specified when we were defining functions, we have parameters that we specify for this method. And they're given in this way where you can actually put sort of a prompt in front of each one of them, so that your method names are very descriptive, and you can describe what the argument is actually going to be used for.
So I guess if we think of it a little bit like our C function, where it just had a list of parameters,
right?
What we have to do in Objective-C is we actually have to give each of those parameters a name,
precisely,
as well,
yeah,
as part of the method declaration.
Exactly. Now, another interesting thing about the method signature declaration is that you have this little hyphen in front of the declaration. The hyphen indicates that these are object methods. So in other words, they are methods that can be called on an object, which is, as we talked about before, an instance of our class.
Right, so when we have the instance of our dog,
right,
and we asked it to bark because of a bark method,
right,
that's going to be one of these with the minus, because the bark is an instance method of dog.
Correct.
Okay.
The other aspect of this, the other character that you might sometimes see in these method definitions, there would be a plus, which would indicate that it is a class method. These are methods that are called on the class object versus on the object itself. Right?
We're going to deal with those later.
And we're going to deal with those later.
Okay.
So for right now, we're just going to concern ourselves with object methods, which they'll always have hyphens in front of them. Then you'll have the return value. Then you'll have the method signature with its parameters, right? Just like that. Then finally, at the end of the interface definition, you have an @end line, which indicates the end of that interface. So you're always going to have this at the beginning. You're going to have the @interface, and then at the end of it, you're going to have the @end. Okay, that right there declares the interface for this class, foo.
So we have declared a class called foo, which contains 3 instance variables. And there's 3 pieces of data within each instance. It's got some properties, which we'll deal with what they are later, and 2 methods which will operate upon the instances of this foo class.
Exactly. So this is the interface, which is done in the header, right? And then we can jump over to the implementation, which is done in the .m file. Now again, we have the well, of course, we have to import our interface just so that we have the method declarations in there. Mm-hmm. Then we have the implementation line. Just like we had an @interface line, we have an @implementation line. And we say @implementation, whatever our class name is. We don't have to tell anything about the inheritance at this point of things, because we already did that in our interface definition. Then we have some more housekeeping for our properties. And we'll talk more about these synthesize lines when we look at properties. Just know that these are here also for our properties.
Okay.
Then we actually have the implementation of those methods that we said that we were going to create. Okay. And again, I don't have any code in here, but the idea is that you are going to do exactly the same thing that you did with your function definitions. You're going to put in that same method signature, and then you're going to have curly braces, and that's going to have the code that will actually execute when you call each one of these methods.
Okay.
Now, one interesting thing that I'll just point out here, it's not technically, I think, part of the specification, but something that I like to do when I'm writing Objective-C, is it's perfectly legal and okay to have a semicolon at the end of your method definition here. Okay, it's actually okay to do that. Now, I like to do that because it also gives me, I can then make changes to this, and then if I want to copy that into my header file, I can just, what the heck am I doing there? I can go to the beginning of that line and copy it and jump over to my header file and just paste it right in. If I make a change to that method signature or something like that, I don't have to remember to put the semicolon on the end of it to drop back over to the
I do that as well. I know several people do that, and I also know a bunch of people that really hate that.
I have heard that people do.
It is. If you want to start a real war, just open this discussion up somewhere.
So that's why in our example code, we actually won't do it, but just know that you can if you want.
And we do.
Yeah.
So it must be right.
So anyway, so basically that's the gist of defining a class. So if we go back and we think about our dog inheritance thing and everything like that, just to kind of extend this and give you an idea of how that would be expressed in Objective-C, here's an example of using, we have an @interface dog, right? And again, we're showing that it inherits from furry creature, right? Which was that superclass that we had. Again, we have these methods that are specific to the dog class, and we can, in our implementation, we can actually create those methods and so forth. Now, if we wanted to, let's say for example, in our dog class, well, we override the vocalize method, right? That was one of those methods that we wanted to, that we said that we wanted to make. So in other words, for a dog, you're gonna have the dog bark when instead of say meow or whatever, right? Now, you might have a case where, for example, the superclass's vocalize method might have some kind of housekeeping that it has to do before the creature's actually going to vocalize. For example, it has to take a breath, and it has to open its mouth, and so on. So in those cases, you might actually want to call the superclass's version of that method. To do that, you can actually use a special keyword called super, which will allow you to call that method on the superclass. So this section of code right here where we're doing super vocalize actually will call the method on the superclass.
Right, so because we've overridden the vocalize method simply by redeclaring it,
Yes.
when we're in a situation where vocalize gets called on a dog, it's going to call this version instead of the furry creature version. But we've decided we actually want the furry creature version as well, and so we're doing that by saying super vocalize, which means call the vocalize methods on the class that I inherit from.
Right.
Equally, that might be calling super vocalize, which
Yes.
might be calling super vocalize, and all the way
Yes.
back up,
Yes.
back up the list. So we can. It means we don't have to rewrite all the functionality. We can add to the functionality.
Exactly, exactly. Now, there's another special keyword that you can use also if you want to call methods on yourself. So in other words, if I am an object, if I am a dog, and I want to, well, for example, in this vocalize method, I want to call the bark method because that's my version of vocalizing, then I can actually use the self keyword to call the bark method.
Okay. There's weird square brackets in there.
I'm glad you asked. That's where I was going to go next, was exactly that. So, I've been talking about calling these methods, and, when we talked about calling functions before, I mean, we did this thing where we would call the function name and we do the parentheses and things like that, right? Well, when you're using objects, you don't call methods on objects using that syntax. In Objective-C, they introduced this new syntax which uses square brackets. And the idea is that what you do, well, actually probably a better example rather than using self would be, let's say we had a dog and we wanted to call the dog's vocalize method. Then what you do is you do dog vocalize like that. And the idea is the first thing, so you're going to put these into square brackets, and the first thing in the square brackets, right after the opening square bracket, is going to be the object that you're actually going to call the method on.
So that is going to be probably, I mean, maybe a little confusing because we've called it dog, but that's going to be a variable
Right.
of type dog.
Right.
Okay. Do you know what? There's something coming out to me here that I don't think we've mentioned before here, that all these things are case sensitive.
Indeed, that's true. They are all case sensitive. The whole language is case sensitive. So you have to make sure that you have all of your P's and Q's, as it were, minded.
So there we'll assume we have a variable called dog, which contains an instance of the dog class, and we're telling that variable dog we'd like it to run its vocalize method.
Correct. And similarly, let's say we were dealing with that foo object again. Let's say we wanted to create one of those foo, we've got a foo instance there, and we'll talk about creating objects shortly. But so we've created this foo thing, and we say foo some method with argument 1, and let's say we passed in blah there and arg2.
And we'll deal with what that string
5.
syntax is in a minute as well.
Right. So here we're calling another method, some method with arg1 and arg2, right? And the idea here is, again, there's our object. Then after that, there's our method. And each parameter is passed, so you have some method with arg1 colon, and then the actual value that's passed into that method. Same thing with argument 2 and the value that's passed to that method. So that's basically how you call a method. Now you can also, of course, you can return values from these. Let's say that this actually returns something, so you could store this into, some variable there. But you can also have methods that return other objects. And so sometimes you can do things like, for example, foo some method, right? And then you want to actually, it's going to return an object, and so you're going to call some other method off of that guy. So by doing that, okay, what's actually happening here is we're nesting these calls with these square brackets. So the first thing is, that's the first object and the first method, and that guy returns an object, which is right there. So that's a new object now that we get back from that, and then we're calling some other method off of that new object.
On the new object. Okay, so we need to understand that you need to break each. So each call is broken down within square brackets.
Correct.
And that will have, in this case here, when you see it in this method, in this format, it means that that call has had a return result, and the return result is then being used as the object for the next method to be called on.
Exactly.
So on and so on, almost ad infinitum.
Exactly. You could stack these things as much as you want. It would look horrible, but you could do that.
So I mean, maybe we can make that clear just by breaking that code out into 2 lines of code. So just in case someone hasn't quite got that yet, that line of code there is the equivalent of something like.
So let's say we actually had a bar class that came back from the sum method.
Yeah.
Right. So we do foo sum method. Right. You could just as easily do that and then do bar some other method.
So effectively, those 2 lines and the line above it are the same.
Exactly. So that and that are exactly the same. It's just that you're cutting out the temporary variable there. It's implied that the return from that is there. It's just kind of hidden and anonymous. Mm-hmm. So square brackets are one of those things that non-Objective-C programmers have a lot of trouble getting their heads around.
Took me ages to get used to them.
It's a big deal. In fact, I would say that that's one of those things that people cite as reasons that they hate Objective-C. On the other hand, I've heard that Objective-C programmers should have as their gang symbol. So you get used to it.
Once you get used to them, they're fine. It's syntax. I mean, what's wrong with it? But it's because there's no other language I know of that uses that type of syntax. It just feels strange if you're coming from another language, but eventually it becomes familiar, like all things do.
Exactly. I mean, once you get your head around it, once you get used to it, it becomes kind of second nature. The only thing that I guess kind of continues to bother me with square brackets is I tend to not think about what I'm writing until I'm sort of halfway through it. So I'm writing, and then I go, oh gosh, I actually want to chain another method in here, and so on and so forth. So I have to constantly be jumping back to the beginning to add another square bracket onto the beginning of it, because I'm going to be, chaining, kind of like what I did right here. I started by typing out, foo sum method. And I said, and then let's say I wanted to add another method to that. Right now I have to go back over here and add that square bracket over there.
But Xcode's become quite good at dealing with that.
It has. Over the last couple of years, they just added a new feature that enables it to kind of do pretty good detection of when you want to do something like that. So if I were to do exactly that right now, and then start doing some other method here and do that, see, it goes back there and it jumps back there and it fixes it for you.
Most of the time.
I would say maybe 50% of the time. That's my feeling.
Yeah.
But that said, I mean,
enough to make it worthwhile.
Yeah, it's a worthwhile feature. I guess I spend less time correcting it than I would correcting my own mistakes, so it's all good. Anyway, so we're kind of a little bit ahead of ourselves there, only because we're going to talk about how we create objects and how we call methods on them and stuff like that shortly. But because we're already starting to deal with these super keywords and the self keyword and stuff, it's a good time to kind of mention the square brackets. This is how we call methods on there. So the important things to know about this are that when working with objects, the method definitions, even though they're very similar to function definitions, they do have a different syntax for their declarations, right? We saw that with the hyphen, the parentheses, the named arguments, and so on and so forth. That said, of course, the arguments that we're working with here, these types and so forth that are specified here in parentheses, they're the same types that we've been dealing with when we're looking at functions. Although, of course, they are specified in parentheses there as well. So, you didn't do that in the functions. You had one set of parentheses that encapsulated all of the arguments. So you need to have those parentheses around the type for each of the arguments as you go through.
Yeah, I mean, that one might look a bit weird because we've not dealt with NS string yet, but
Right,
if we
but
just
if you
move
look at
along
the
to the
next
second
one-
one where there's just an integer
Right.
parameter, it's syntax again.
It's the same thing that we dealt with
Took me
functions.
ages to get used to that one as well. Yeah, the fact that
Yeah.
you mark it in there as in parentheses. Don't ask why, don't care why, just do it and it's fine.
Right. Well, if you're already a C programmer or you're already a C++ programmer and you're familiar with the concept of typecasting, which is something we'll talk about a little bit later, but you can take, essentially it sort of follows the same syntax as typecasting, and you can almost kind of think of it like that the argument that you're passing in is being typecast as that argument. So you can almost, that's not really what happens. It's not really doing typecasting, but it almost kind of feels like it with that syntax. It looks like typecasting, so you can kind of wrap your head around it in that way.
That's good enough for me.
Anyway, so basically, that's the gist of how you declare and define a class. Now, a couple of things that we should probably talk about here is, again, Objective-C is a single inheritance language, so you can never have more than one class that you can inherit from. All classes inherit from only one class. Now, there are some language constructs that let you kind of work around that, specifically things like categories, right, where you can kind of bolt on functionality without necessarily inheriting from a class. But the important point here is there will only ever be one class that's listed as your inheritance here. And that's pretty much the gist of how you define a class. There's other aspects of this that we'll be dealing with as we go, but this is probably the simplest form of declaring a class.
Okay, so we've looked at class declaration. We've sort of been off on a bit of a tangent and started looking at some of the calls, but we'll be coming back to a lot of that as well, so you'll get a second chance to hear that. So we've created our template. I guess next we're going off to find out how to turn our template into an instance of...
Yes.
Okay, so take a look at this code and then we'll be back.